Before I start with the phases, I want to remind you that we only see one side of the moon. The reason for this is explained nicely in the following clip.
To simplify our discussions, let's hold it still for now. Also, let's add a yellow line so to make the rotation of the moon more apparent. Note that as the moon rotates, the line goes from vertical to horizontal to vertical to horizontal and so forth. That means it's rotating. What if the moon didn't rotate and it only revolved around us, like this? We'd still be able to see all sides of the moon, right? What if the moon both rotated and revolved? How about like this? Look carefully, and you'll see that, yes, we still get to have a 360-degree view of the moon. No hidden sides. But what if the moon rotated just as fast as it revolved? Like this. Ooh, check this out. The moon is rotating, right? Look at the line, if you don't believe me. Vertical, horizontal, right? But it's rotating at a rate that matches the revolution, just so that only one side of the moon ever faces Earth. And that's exactly the situation we find ourselves in today. The only side we ever see we call the near side. The side we don't ever see we call the far side.
Let me set up these reference points. We draw two lines to divide up the area around Earth into quarters. This is the first quarter, followed by the second, third, and fourth. The first quarter goes like this, and so on. We have the Earth showing daytime on the left and night on the right. Now keep in mind that whenever we see any part of the moon, it is sunlight reflecting off the moon's surface. The moon itself puts out no light. We'll start at the fourth quarter, which is really the end of the fourth quarter, and the beginning of the first quarter. When the moon is here, between Earth and the sun, we call it the new moon. It occurs during daytime and is invisible. This is because the lighted side of the moon is facing away from us. The moon rises along with the sun on that day. Now you may say, if the moon is in this position between Earth and sun, that is eclipsing the sun, and the moon goes around the Earth every month, shouldn't we have a solar eclipse every month? Occasionally this does happen, but why it usually does not will be explained after I go through the phases. About 7 days later, the moon is in the first quarter position. We call it the first quarter because the moon has completed 1 quarter of its cycle. When we see the moon at night, it looks half lit and is commonly called a half moon. Not everyone will see the same half of the moon lit up because it depends on their location. Here is the view from the southern hemisphere. It's the other half of the moon. And here is the view from the equator. There is an in-between phase here, but I will do the 4 quarter phases first. At the second quarter, we have a full moon that is completely illuminated by the sun.
By the light of the silvery moon.
And here is the view from the southern hemisphere. It is the flipped version if you look carefully. In this position, the moon looks to be eclipsed by the Earth, so why don't we have a lunar eclipse? Occasionally this happens, and this too will be explained after all the phases. At the 3-quarter mark, the moon is lit up like the first quarter, but on the opposite side. Here are the views from the northern and southern hemisphere and the equator. After 1 lunar cycle, lasting 29.5 days, we are back at the new moon. I want to pause here a moment to discuss views of the moon that are shown on calendars and images from the internet. For example, this set shows typical icons of the 4th quarter, but they are not meant to be accurate, although the full and new moon icons are accurate. These images show the moon pointing along a 3 o'clock line like this. But these views are only correct from the North Pole. Anywhere else in the northern hemisphere, the moon will be at an angle something like this. I have used images for the phases that are correct for Toronto. I should also note that the moon's direction will change over the course of a night quite dramatically. For example, here it is at 3-hour intervals. The area of the moon that is illuminated does not change during the night, but our perspective of the moon changes because the Earth is rotating. Our line of sight changes. Now let's return and complete the other phases. Here's another reference line halfway between the quarters. The moon appears as the familiar crescent. It starts out as a bare sliver of a crescent after the new moon and gradually grows larger as more of the moon becomes illuminated. The word waxing means growing, so this is called the waxing crescent moon. As we continue, more of the moon becomes illuminated, as we see in the first quarter, and is therefore waxing. Here, between the first and second quarters, the moon looks like this. It is not yet completely illuminated. You can see here that there is some darkness. This gives the appearance of a bulge. To the ancients, it looked like a hump, and in Latin the word gibbosus means humped back. So this is called the waxing gibbous moon. After the full moon, see how the shadow is encroaching now on the right side so that illumination is now decreasing. The word for decreasing is waning. So although it is still gibbous in shape, this is the waning gibbous moon. And finally, after the third quarter, less and less of the moon is getting sunlight, and we have the waning crescent moon. At the end of the fourth quarter, when we start the lunar cycle all over again, the sun and moon rise at the same time. So these are the 8 phases of the moon. One more thing. We often see a crescent moon like this along with the rest of the moon. How is this explained? Strange as it may seem, we see the rest of the moon due to Earthshine. This is light coming from the Earth and illuminating the unlit part of the moon. That is, sunlight hits Earth, and some of it is reflected up to the moon, and some of that is reflected back to us. That's why after 2 reflections it is much dimmer. Finally, we are ready to answer the earlier questions about why we don't have more lunar and solar eclipses. The answer lies in the fact that the moon's orbit is not on a constant plane. Here's a picture that shows that there is a 5-degree tilt of the moon's orbit. Because of this orbital tilt, it means that most of the time the moon will be either above or below the orbital plane of the Earth, and so no eclipses will occur. But about twice a year, the alignment of Sun, Earth, and Moon will be such that either a lunar or a solar eclipse will be possible. The exact mechanics of how this occurs is beyond the present topic of the moon's phases, and so I will not pursue it further here. Now that you have seen all the phases, can you apply this knowledge to the title page? You should be able to pick them all out. Let's start here with the new moon. Since it is invisible, I will add the yellow circle to indicate it. The crescents on either side are the beginning and ending of the cycle. Start by going to the right, and notice how there is a gradual increase in illumination. That is, the moon is waxing. The gradual changes continue on the other side, where the moon is waning. So after the new moon, we get a waxing crescent. Then we come to a half moon, which is the first quarter, followed by a waxing gibbous moon, and then the full moon, which is the second quarter. Now the waning part starts with the waning gibbous moon. Here is the half moon, the third quarter, and the waning crescent, and ending with the fourth quarter, and a new moon begins again. This ends the video on phases of the moon.